Okay, so just to continue with this question, we're saying that cos of 60 is a half. So there's your half, there's your 60 on the graph. So if I was to go over, I see I've got the same value over here at 300 because I know this is 90, this is 60. So this is 30 degrees before the 90. So this is going to be 30 degrees after the 90. So in the same way, if I'm looking for 240, I can see that, well, that's going to be 30 degrees before 270, which means this 120 will be 30 degrees after, and they're both going to give me the negative a half. So see there, the 60 and the 120, 30 degrees before, 30 degrees after, we've got the same value but negative. Now, that to me makes sense, but maybe a better way of thinking about it is to get our cast diagram out. And we know that we've got x, we've got 180 take away x, 180 plus x, and 360 take away x. So let's see, so if x is equal to 60, which is what we've got, isn't it? We're saying the cos of 60. Well, what does that look like in quadrant 2? Yeah, so this is quadrant 1 in here. What is that corresponding value in quadrant 2? Well, 180 take away 60 is going to be 120. So it's that value in there, isn't it? Just like we said. But it's negative. Yeah, we know that cos is negative in here. It's positive here. It's negative here. So 180 take away 60, 120. But it's going to be a negative value. So it's got the same value, but one's positive, one's negative. 180 plus the 60, that's going to be 240, which again, I'd shown you over here. And this again would give you a negative value. And in this quadrant, so there's quadrant 3, so I just did the quadrant 3 one, and in quadrant 4, 300 take away 60, so 360 take away 60 would give you 300, and that would be a positive value. And we're up here, aren't we, positive? So all those values are the same. It's just that these are negative and these are positive, and we can see that on the graph. So I was just kind of looking for symmetry, about the points that I knew, but you could have just used distant populate it. Okay, so I hope that's quite an interesting question. It makes you think a bit more about it visually, but basically you could have just popped it into your cast diagram. Yeah, so anyway, on we go. So let's solve this one. So this is the same as what we were doing before. So I'm going to say that sine x is equal to, so it's 7 sine x is going to be equal to 1. So sine x is going to be equal to 1 over 7. So then x is equal to sine to the negative 1, 1 over 7. Now this is just positive. This is great. I don't actually have to change this sign. It's positive, so I'll put it in positive. Recently we've got a lot of negatives. So shift sign of that. That's going to give me 8.21 degrees. And I need to do a cast diagram to get my two answers. So like we said before, step 1, rearrange. Step 2, do your shift sign. Step 3 is the cast diagram, and step 4 is your final answers. So which two quadrants is sine positive? Well, it's positive here and here. I've got sine x is positive 7th, so I'm in these two quadrants. So quadrant 1 and quadrant 2. Quadrant 1 is just the answer we've got. It's just x, yeah? Just x. And this one is 180 take away x. So quadrant 2, 180 take away 8.21. So that's going to be... So lazy, I should really just do this in my head. But it's getting late, I'll just call that off and I'll round it the way I've got it written down. 7, 9, okay. So that's a nice easy one when it's positive. I'd say it's the easiest type because you're just working in your, this is the first two quadrants, but the point is you're not changing this, okay. If this is negative, you need to put this in as positive. Okay, so this is always positive in here, and then you sort your negatives by using the right quadrants. So this was sine x to the negative 7th. I would do the inverse sine to positive a 7th to get this, but then I would say I want these two quadrants and do 180 plus x and 360 take away x to give me my two answers. Okay, that's the only trick of it. And very finally, slightly bigger question here. So I've got a turbine that's spinning round. I'll let you have a little read at that actually. Feel free to pause the video. Yeah. So I've got the tip of blade A. The height of that above ground is given by that equation. So that's the height above the ground. and X is the angle blade A is turned clockwise from its vertical position. So there's vertical, so the X is, that angle there, isn't it? How far I've gone clockwise from the vertical. So calculate the height of the tip of the blade after it's turned through 60 degrees. Okay, I'm going to zoom out so I've got some space to work over on this side. So for A, really all it's saying is calculate this when X is equal to 60. That's not too bad, is it? So cos of 60 times 23 plus 40. So that's going to give me 51.5 meters. So not much in that, but you've got to kind of get through the jargon of the question. What's it asking? But calculate the height. So calculate h when we know it's gone through 60 degrees, which is what x is. Find the minimum height of the tip of blade A above the ground. The minimum height. So blade A right now at 0 degrees. So when x is 0, that's a maximum, isn't it? Yeah, right at the very top. So if we get cos here is 0, that's going to come out as 1. We should know that our cos graph is like this. Yeah. So it's a maximum of 1, negative 1. So if we put in cos is 0, this becomes 1, so that'd be the maximum height. So our maximum height is looking like 40 plus 23. The minimum height above ground will be when the blade comes all the way round to here. So that's 180 degrees, which again, 180 degrees is going to give you negative 1. Yeah. So B is simply saying h is equal to 40 plus 23 multiplied by negative 1. So that's going to give you 40 take away 23, which is 17 meters. Yeah. That's the minimum height of the tip. Yeah. So the minimum 17, so that's the lowest it's going to get, is 17 meters. And we've worked out already that the maximum it can be is, we just said that was the 40 plus the 23. So that'd be 63 meters for the min and the max. Okay. Nice one. So calculate the values of x for which the blade, for which the tip of the blade is 61 meters above the ground. Okay, so when it's 61, the height is 61, and my equation is 40 plus 23 cos of x. It's the exact same as before, it's just rearranged. So take away 40, so that's 19 is 23 cos x. Then 19 divided by 23 is equal to cos x. So x is equal to inverse cos of 19 over 23. So calculators out. 19 divided by 23, shift cos of the answer. So that's going to give me 34.3 degrees as an answer. Let me just double check that. Yeah, sorry, oops, made a little mistake there. That was obviously not 19. Sorry if you were screaming at the phone. That should be 21. Oops, the daisies. That said, getting late, getting late. I say that all the time. That's my excuse. 21 divided by 23, shift cos of the answer. 24.1 degrees. That looks a lot better. So yeah, whoopsie, I would have lost a little mark there for poor arithmetic. Shocking. 24.1 degrees. I'm not quite finished. I want the two values, so I need to double check with my cast diagram. When is cos positive? It's positive here and here. So in quadrant 1, it's simply just the x value. So 24.1 degrees. In quadrant 4, it's 360. Take away the x value. You should remember that from before. So that's 335.9 degrees. Nice one. So I'd say, these are one of your harder questions at the end. But when you look at that, wow, it's very contextualized to kind of confuse you. But, look at your equation, just think about it. When is the cos max and when is it min? So even just looking at it, like, well, cos is 0, when it's cos 0, it gives you 1. So that was, I think, a good thing to think about. And this one, all you're doing is substituting in the 61 and solving. So read the question, there's two variables here. They're asking you to solve one of them when they give you the other one. So it's just a rearrange. So look, I hope that was helpful and best of luck.